about the zero knowledge proofs in the blockchain technology. A zero knowledge proof is a way of proving the validity of a statement without revealing the statement itself. Here, the prover is the party trying to prove a claim, while the verifier is responsible for validating the claim. As in the zero knowledge protocol, there are two persons, that is the prover and verifier. So here the prover wants to prove something true to the verifier, so without revealing that particular information, and prove that, so without revealing the information, so he has to prove that his claim is valid. So now let us see an example. So here the prover is knowing a secret X, and he wants to convince that to the verifier that he knows the secret X without revealing the secret X. Okay, so he wants to prove his claim that he knows that particular statement. Okay, so he don't want to reveal that statement itself. Instead, so he want to make the verifier understand that he knows that particular statement. Okay, so here the prover is knowing the secret X without revealing the secret X. So he has to convince the verifier that he knows that secret X without revealing that statement X. For example, you visited another country, and there you have to prove a claim that I am a citizen of some X country to another party, that is a service provider. So you should provide the evidence to back up your claim, such as national passport or driver's license. So here you are the prover and the verifier is the service provider. Okay, so we have to prove that you are a valid person without revealing your personal information, that is without showing your passport or driver's license. Okay, similarly, there is another example. You want to book a ticket for a movie, so which is a horror movie, and to watch that movie your age must be 18 plus. Okay, so instead of so to prove your age, you have to show your personal identification card, like your ID proof or your Aadhaar card. So without revealing your personal information to the verifier, so you have to prove the verifier that you are above 18 plus. You are above 18. Okay. So here you are the prover and the verifier is the person who is booking the ticket. So he will book the ticket only if you are above age 18. Okay. So these are some of the real-time examples of the zero knowledge proof. So the verifier has to he has to accept the claim of the prover without any knowledge about that information of the prover. Okay. So the verifier doesn't know anything about the information of the prover, but he has to accept that information. So he has to accept that information. So now let us see some of the zero knowledge proof applications. So applications are blockchain, online voting, finance, authentication, and machine learning. So these are some of the real-time applications of the zero knowledge proof. So we know that use the Bitcoin and Ethereum for cryptocurrencies, and these Bitcoin and Ethereum are they are public blockchains. That means the information is available it is open to everyone. Right? So there is a little privacy, and it can lead to de-anonymization of users. So here in the public channel, in the public blockchain, everything is open, and we know that the blockchains are anonymous. Okay, so here it may lead to some privacy and can lead to de-anonymization of the users. So in this case, zero knowledge proofs can be introduced to increase the privacy for the public blockchains. For instance, The cryptocurrency Zcash is based on the zero knowledge proof. So next one is the online voting. Zero knowledge proofs can allow voters to vote anonymously and to verify that their vote was included in the final tally. So next one is the finance. Finance allows the customer, here the zero knowledge proofs in the finance allows the customers to prove that their secret number lies in a known range. For suppose an applicant can prove that their income is in the admissible range without revealing their exact salary. So next one is the authentication. So you might gone through this application authentication. Suppose you are logging to Gmail using a new device, or if you have forgotten your Gmail password, then it will the Gmail will ask some questions randomly to you to check that whether you are the authorized person who is accessing that Gmail account. So in the authentication, the zero knowledge proof can be used to authenticate the users without exchanging secret information such as the passwords. So next one is the machine learning. It can allow the owner of a machine learning algorithm to convince others about the results of a model without revealing any information about the machine learning model itself. Let's say you, the prover, have a buddy who is colorblind and unable to tell a red ball from a green one. That means he is having zero knowledge about whether the balls are of different colors or of same colors. So your friend requires more than just your words to be convinced. So you must provide evidence that the colors of the balls are different. So a zero knowledge approach is used to solve this kind of problem. So your buddy will pick up the ball and show you which one is in which hand. Then they either switch the balls between their hands or do not move the balls behind their back. So they can show you the balls and ask if you believe that they were swapped or not. Because you already know here, because you can tell the difference between the green and red balls, you can readily provide the correct answer. So your buddy is not satisfied. So you have a 50% chance of accurately guessing whether the balls were switched or not. And the balls could be the same color. However, if they do this several times, the chances of you accurately guessing whether they switched the balls or not each time are very low. This allows your friend to confirm that the balls are of different colors without understanding what they are. Suppose if you repeat this exchange of balls several times, so by your answer, your friend will get convinced that whether the balls are swapped or not, or what is the color of the ball. So now let us see how the zero knowledge proofs work. A zero knowledge proof allows you to prove the truth of a statement without sharing the statement's contents or revealing how you discover the truth. To make this possible, zero knowledge protocols rely on the algorithms that take some data as input and return true or false as output. So here we are having the three properties of the zero knowledge proof, that is completeness, soundness and zero knowledge. So in the completeness, if the input is valid, the zero knowledge protocol always returns the true. Hence, if the underlying statement is true and the prover and verifier act honestly, the proof can be accepted. The next one is the soundness. If the input is invalid, suppose, then it is impossible to fool the zero knowledge proof protocol to return the true. Hence, a lying prover cannot trick an honest verifier into believing an invalid statement is valid. So next one is the zero knowledge. The verifier learns nothing about a statement beyond its validity or falsity. So they have zero knowledge of the statement. This requirement also prevents the verifier from deriving the original input, the statement's contents from the proof. Now let us see some of the elements of the zero knowledge proof protocol. So it is made of three elements, that is witness, challenge and response. So with a zero knowledge proof protocol, the prover wants to prove knowledge of some hidden information. The secret information is the witness to the proof, and the prover's assumed knowledge of the witness establishes a set of questions that can only be answered by a party with the knowledge of the information. Thus, the prover starts the proving process by randomly choosing a question, calculating the answer, and sending it to the verifier. Next one is the challenge. The verifier randomly picks another question from the set and asks the prover to answer it. And in the response, the prover accepts the question, calculates the answer, and returns it to the verifier. The prover's response allows the verifier to check if the former really has access to the witness. To ensure the prover is not guessing blindly and getting the correct answers by chance, the verifier picks more questions to ask. By repeating this interaction many times, the possibility of the prover faking knowledge of the witness drops significantly until the verifier is satisfied. Suppose let us take another example. So sometimes if you are logging into your Gmail, so it will show some pictures and it will ask some questions that whether you are a robot or not, who is logging into the Gmail account. So to prove that, so it will randomly send it will display some pictures and it will ask you to select some similar pictures. So here you got the prover and the verifier is the Gmail. So it will show some pictures and it will ask you to select that particular pictures in the set of pictures. So it will randomly ask that pattern of pictures repeatedly until the verifier gets satisfied that so you are the valid prover. So that one only. So we are applying in the three elements of the zero knowledge proof: witness, challenge, and response. So now let us see a famous example of the zero knowledge proof. So this is a story about the Peggy and Victor who wants to enter a cave, that is Alibaba cave. Okay. So there are two friends, that is Peggy and Victor. So here the Victor is waiting outside while the Peggy has entered into the cave. So here the Alibaba cave is a ring-shaped cave with the entrance on one side and the magic door blocking the opposite side. Peggy claims to have uncovered a secret word that opens the magic door, but she don't want to say this word to the Victor, who is waiting outside the cave. At the same time, Victor wants to learn whether Peggy in fact knows the secret word. So Peggy and Victor agree on naming both paths. So let's call the paths in the cave as A and B. Then Peggy takes a random path without Victor seeing which path Peggy chooses. After that, Victor enters the cave and shouts the name of the path he wants her to use to return either A or B, chosen randomly. If Peggy knows the secret word, she has no problem returning to Victor using the correct path. But if Victor calls her only once, Peggy has a 50% chance of being lucky if Victor calls here to return the way she entered the cave initially. That's why Peggy and Victor repeat this activity multiple times. So after each repetition, Victor becomes more confident that Peggy knows the secret word. Victor's confidence will rise after repeating this process several times, but never precisely 100%, since there is always a chance that Peggy was lucky in all repetitions. So here we will see what is the process that Peggy and Victor repeat. So first of all, Peggy will enter the cave. So Peggy takes a random path, that is either A or B. So Victor enters the cave and then Victor shouts a name of a random path. Peggy returns using the path Victor shouted. In case if she don't know the secret word and got unlucky, she returns the same way she came in. Okay, so this process will repeat until Victor gets confidence that Peggy is going in a right path. Okay, so this is about the Alibaba cave example. So thanks for watching my video on zero knowledge proof. Thank you.